The last section of our similarity unit is going to look at what happens when we do composite transformations, which basically means multiple transformations. So sometimes these composite transformations have special names, and a glide is one special case. And a glide is when we reflect, it is composite of a reflection and a translation. Okay, and so what we're going to do is we're going to see this reflection and then we're going to slide it, or we slide it and then we reflect it. This is one composite transformation where order doesn't matter. So if we look at this figure, we can see that it was reflected over the x-axis, and then it had a transformation of 1, 2, 3, 4, 5, 6, but it did not go up or down at all. And so we get this glide from our first to our second. We can, in the case of glides, write them as a composite, as a single transformation. So our reflection over the x-axis rule, if we look at our rules, is going to be x minus y, and our translation rule, and we think about combining them in a single step, we can do that by adding 6 and doing the opposite on y. Not all composites can be written as a single transformation, but by examining and testing, so after you write the rule, you'd want to look at B, which is at 2, 2, to B double prime, which is at 4, whoops, that was -2, 4, -2, and make sure that if you run it through this rule, it actually works. One other quick homework notation is you'll see some additional notation in the homework particularly. You're going to see something like r of y equals x, little circle that's composed with r of 180. This is a composite reflection where first you rotate 180, then reflect over y equals x. So we work inside out when we do these composition reflections. You'll also potentially see dilation 2, so that is k equals 2 scale factor, blow everything up by 2. You may also see an r3, 4, that is a translation of x plus 3, y plus 4. We just give the coordinates of how we are translating it. But the main key is that you do inside then outside, because as we're going to find out, order often matters with compositions. So let's look at that exact issue right now. So first we're going to dilate. Sorry about that. First we're going to dilate by 1/2, then reflect. So a lot of times I will write my rule like this. And to reflect over the y-axis, we need to do the opposite sign on the x and leave the y alone to get things to move across that y-axis. So that's my order. Then I'm going to list my coordinates. So r is at -4, 6. So then R prime is at -2, 3, and R double prime is at 2, 3. So 2, 3 is where our double prime will end up. Y is at 2, 4. So Y prime is at 1, 2. And Y double prime is going to be at -1, 2. So you're seeing the shrinking and the flipping. You could, if you wanted, graph this middle step and then do it again, or you can skip that. It just kind of depends on what you want to see when you're doing your transformation. So W is at 2, -2. So W prime is going to be at 1, -1, which means, whoops, 1, -1, and double prime will be at -1, -1. So I'm getting smaller and reflecting at the same time. And my last point of L is at -6, -2. So L prime is going to be at -3, -1, and L double prime will be at 3, -1. Oops, I graphed W in the wrong spot. -1, -1, -3, -1. So here's L prime, double prime, double prime, and we see we have the same picture reflected and shrunk. Now, the question is, when we have those, what happens if we do the reflection in the other order? So if I first do opposite x, y, reflect over the y-axis, then I shrink it by 1/2. What will happen to my coordinates? So I'm going to pause the video, do this work, you do the same, and turn it back on when you have calculated your R double prime, Y double prime, W double prime, and L double prime. So after you've done that work and you find out that R double prime is at 2, 3, Y double prime is at -1, 2, W double prime is at -1, -1, and L double prime is at 3, -1, and you graph it, you see that in this situation, the order didn't matter, that my figure ended up being in exactly the same place. When we do the next composite transformation, though, you're going to see an entirely different scenario. So tune into the next video to see that.